Hi guys, at this point we should be getting fairly familiar with how to use both single and multi-value variables, so the singles being nums and strings, multis being tuples, arrays and dictionaries. We covered topics in the previous two sections such as how to store values in variables, how to retrieve values from variables, as well as how to modify existing variables' values. So we're going to apply all of the stuff we've learned there to this new topic, which is going to be on control flow, to basically implement some logic within our code. What this will allow us to do is choose which parts of the code we want to execute and when and where we want to execute them, based on the outcome of some logical tests. Now, as an aside, when I say execute, I mean run the code. It's going to be pretty much the same thing. Now, control flow has many forms. We're going to be covering just a few of them. First, if, and else statements, and then while and for loops. But essentially they function more or less under the same pretense. So we're going to test some kind of variable's value. This is typically comparing it to another value. For example, if I had a variable x and I wanted to see what value it could contain, I could write some tests. So is x greater than this value? Is x less than this value? Is x equal to this value? And those tests will return some kind of true or false result. Based on whether the result is true or false, we can choose to execute code block A or code block B. And those are the basics of if and else if statements. While and for loops are a little more complex, but if we can understand these, then we'll be able to understand these. This is a really nice concept to understand, because once we get to know control flow a little better, it's going to allow us to pick and choose again exactly where and when we want to execute certain parts of the code, rather than executing every single statement that we write line by line, which is what we've been doing so far. So we'll get started in a new file. Unless you want to keep everything in the same file, just be sure to comment out all the old stuff. I called my one controlflow.py. Just make sure that when you run this, you go to your run menu, second run window, and you want to choose your new file or your same file if that's what you've been working in. So I'm just going to choose control flow. It should just give me a blank screen for now. So we're going to start with the simplest form. This is going to be the basic if statement, and I'm going to use the example of a traffic light, weirdly enough. So generally speaking, and I know there are a lot of exceptions, but let's keep things simple. Traffic lights have one of three possible states. Traffic light is either red, green, or yellow. Now I know that there are lots of other states, but let's just assume that's one of these three. And let's keep things simpler still. For now, let's just assume that a light can either be red or green. So my goal here is to print either stop or go, depending on what current state my traffic light holds. Now first things first, I need some way to represent my current traffic light state, and I'll do so using a variable, and I'm just literally going to call this traffic light state. Okay, this is going to be a string, and I'm going to store the value of green within it, whereas it could be red. I'm just choosing green arbitrarily. So the simplest way we'd go about testing to see what value this holds is by comparing it to other possible values. Now the first one we might be interested in is to see if my traffic light state is green. Okay, and if it's green, then we want to print something out, maybe go. And if my traffic light state is red, so it's not green, then I'm just going to print out stop or something. Okay, so let's consider the first case first, where we're testing to see if it's green. So the simplest form might be to do something like this: if traffic light state, okay, equals green. So note first of all the if statement, the if to denote that is an if statement. Then this is a test I'm performing to see if the value that this variable currently holds is equal to this string. Okay, I add the colon to signify the end of all the tests that I'm going to perform in this if block. And then underneath, I'm going to press enter. It'll provide the indent. And here, I'm just going to write the code I want to execute. In this case, it's just going to be printing the word go. Now, this indentation is important, as soon as we exit out of this indentation, we're no longer in this if statement. So any code that I write underneath this is all part of the code that I would execute if this is true. And then if I were to do this and then write some more statements here, this is stuff that will not be executed as part of the if statement. This is going to be executed after this. Okay, this is all garbage code, however, so I'm just going to delete that. So basic if statements always follow the same format. If, and then the test or tests. I'll show you how to do multiple in one later. Then the colon signify the end, the code we want to execute if this is true. And in this case, we don't have an else clause, so that's all we really need to do. So now if I were to actually run this, let's give it a run. As you can see, go is printed out. But what if my traffic light state is red, which means that this test fails? Well, in this particular case, I haven't written the code for that alternative case, so nothing happens. So why don't we enter that in now? And there's actually a few ways we can go about doing this. So I can write an additional if statement to test to see, oh, if my traffic light is red, then I'll do something else. So that's one way of doing things. If traffic light state equals red, then in that case, we'll just print stop instead. And that's fine. I mean, there's nothing particularly wrong with this. And we zoom out and I just ran it. It says stop there. However, it's a little unnecessary in this case because we know, again, this is kind of based on assumptions, that the traffic light state is either red or green for now. Which means that if it's not green, then it's red. If it's not red, then it's green. So realistically, we only need to perform one test at a time. In this case, we're actually performing both tests regardless of the outcome of the previous test. So even if my traffic light state is green, I still perform the second test because it's a part of a different if statement. So again, I can simplify this because I know it's either going to be red or green, and just add an else case to this if statement. In this case, I'm just going to print stop. So this is okay for this example because I know that if my traffic light state is not green, so if this test fails, then it must be red, so I know to print stop. Similarly, if I had these roles reversed and I had if I had red up here and I were to print stop, and I know it's not red, then I know it has to be green, so I would print go. So as you can see, if I were to just go ahead and run this, again, same result, I get go being printed because my traffic light state is green, okay? And similarly, if it was red, then I get stop being printed there. Now, there's a couple of differences between this format and what we saw previously with the two if statements. So the first difference is the fact that this else case is only going to be executed if my first test fails, okay? So this means if my traffic light state is indeed green, or if my traffic light state is red, which it was previously, this fails, and so this does not get executed, therefore I perform this, I execute this bit of code. But if my traffic light state is green, then I'm going to execute this because this is true, so I run this piece of code, and I simply ignore this stuff because this worked out to be true. And this is basically saying if everything above the else clause fails, then we'll execute this. You can think about the else statement as being kind of like a fail-safe. The second difference is the fact that we're actually not testing anything here. The else case isn't performing any more tests, so at most we'll only ever perform one test in this case. Okay. However, we know that traffic lights generally have at least 3 states, so there's going to be a yellow light as well. Well, in that case, all we have right now, the model, is just going to print stop, but that's not exactly what we want. We want something different, maybe slow down or speed up being printed. So what we'll have to do is perform an additional test to see now, okay, my traffic light state could be green or yellow or red. Okay, if it's not green or yellow, then it must be red, so we'll print stop. So we can do this in a few different ways. I think the simplest way would be just to add an elif, which is short for else if my traffic light state equals yellow. Well, in this case, I'm just going to print, let's be cautious, let's just do a slowdown for now. So in this particular case, we've made stuff a little more complex. We're first performing this test to see if it's green. Okay, if this test fails, then we'll perform this test. If this test fails, then we'll fall back on our else case. Additionally, if we wanted to be really safe, what we could do is say elif traffic light state equals red, then we'll print stop. This would actually be a better way of doing things because if for whatever reason traffic light state was something else, or maybe there was a typo, then we could have the else case be print something like unknown action. Okay, don't really know what to do if my traffic light state is, for example, blue. Alright, so it's generally a good idea to have an else case, particularly when working with strings, because strings are very typo prone, which means if we make a typo somewhere and we really needed that string to be exactly the same as some other string, then we're not going to get the behavior that we want. So let's test to see what happens with all of our possible values. So let's start off with green, and I'm just going to zoom out, and let's just zoom out there. So we'll go ahead and run this one. As you can see, go is printed out. Now, what if this is yellow? What happens then? Well, we get slow down printed, that's to be expected. What happens if it's red? We'll get stop being printed. And what happens if it's some, garbage string, something that is different from those? We get unknown action. So this is exactly the behavior that we want. So I just want to change that back to green. So this statement reads kind of like the following. We'll perform this test first. If this test passes, we'll execute this, so we'll print go, and then we'll ignore everything else and basically execute any code underneath. If this first test fails, then we'll move to our second test, okay? If this test passes, execute this and ignore this. If this test fails, then we'll move to the third, and so on and so forth. And if the third test fails, so if all of these tests fail, then we're going to perform this action, which is just going to be print unknown action. Alright, so that's your basic if, and else statements, but we can make things more complex still. So I mentioned earlier that we might be able to test multiple cases in one single if statement. And we can do that through the use of our and or operators. So they look a little like this. First, our and operator looks like this, okay, and our or operator looks like this. So basically, and goes between two tests and signifies that both of them must be true in order for the overall test to pass. I'll explain further in just a second. Or, again, goes between two tests, but in the OR case, only one of the two tests has to pass. The only reason that the OR test will fail is if both of the cases on the left and the right hand side fail. So in order to demonstrate these, let's introduce another variable into the equation, and this is going to be something like distance from light. So yellow light is either slow down or speed up depending on how far away we are from the intersection. If we're right near the intersection, really close to it, then we might as well speed up and keep going through. It's actually unsafe to slow down at that point. But if we're quite far from the intersection and cannot safely make it to the intersection in time, obviously we'll want to slow down in that particular case. So we need to perform an additional test, and there's a couple of ways we can do this. So I'll first finish this off. Let's set this equal to something like 20. And let's write the arbitrary case that if we are 15 meters or closer, so if distance from light is 15 or less, then we will speed up and we'll go through the light. And if it's greater than 15, which is in this case, we'll just slow down because we're an unsafe distance away. So I'll show you both ways to do this, first using the AND operator. So if my traffic light is yellow and my distance from the light is less than or equal to 15, well, in this case, I actually want to speed up, okay? Because I'm quite close to the intersection and my light is yellow, so I'm just going to print speed up instead. But what if my traffic light is yellow and I'm further than 15 meters away? Well, now I have to write an additional case in my if statement here. So I'm just going to copy this and paste it. Just put that indentation properly. So now if my traffic light state is yellow and my distance from the light is greater than 15, well, in this case I want to slow down, obviously, because it is unsafe. So if I now zoom out and go to test this again, I get go, that's green. So let's change my traffic light state to yellow. I'll run this again. Slow down is printed out here because obviously I'm too far from the light, but if I was at 10 meters, let's say, I get speed up being printed out. Okay, so even though the traffic light state was still yellow, because my additional case is different in each of those two examples, then I get a different statement being printed out. So the first test in this case actually passes because this is true and this is true. Whereas in this case, when this is 20, this is true, but because this fails, this whole test fails. Okay, so both have to be true for the AND to pass. Again, this is different from if I replace this with an OR, because in this case, only one of these two has to be true. If both of them are true, that's still fine. It's only if both of these are false that this overall test fails. Okay. So I'll show you actually, in my opinion, a slightly better way of doing things, and that's going to be using nested if statements. So I'm just going to copy this and actually comment it out. And I'm going to just paste it down at the bottom and make some minor modifications. So rather than having this and the and here and adding this extra case, I'm actually going to get rid of this. I'm going to get rid of this. And I'm going to create a nested if statement. So this if statement now is actually going to be separate from this if statement, and I'm going to consider this if, else if, and else to be all part of the same statement here. So now in this case, I'm going to perform an additional test inside of this case. So I'm testing for the distance from the light, and I'm seeing if it's less than or equal to 15. In this case, I'm simply going to print speed up again, and I'll do an else if, or we can do an else because in that case I know it's safe. I'm going to print slow down. Okay. So now this is going to accomplish the same task as above, but it's going to be slightly different syntax. So in this case, here we had 5 parts to this if statement. Well, now we only have 4 parts, but one of the parts contains additional cases within it. So I think this method is actually a little more efficient than this, because we have to perform a possible 4 tests to reach the else statement, whereas here, we only have to perform a possible 3 tests before we reach the else case. And this seems to be the case in a lot of times. This nested if statement is actually more efficient than the AND clause in a lot of cases. If there are lots of different possible values that this can hold, then you'll probably want to consider the nested if statement. In this case, there's only actually a couple of possible values, so it doesn't matter too much. But again, we're going to accomplish the same task. So again, if this passes, we'll ignore everything else. If this fails, we'll go on to this test. Now, if my traffic light state is yellow, then I need to perform additional tests. So now I'm testing distance from the light, and there's the else case there. And again, if this fails, then I ignore all of this and move on to my next test. So like I said, exact same result. If I were to print this out, slow down is being printed. Just like if my distance from the light was 10, we should get speed up, and we do. Okay, so that's the basics of your if, else if, and else statements. I do highly encourage you, if you're kind of confused about what's going on, to take a moment here, pause this video, and try some stuff of your own. So try some different examples. and create some variables, compare the values, and write some if, else if, and else statements to test these. Particularly, use some nested if statements, use your and your or operators, because it's important that you understand these moving forwards. I can't, unfortunately, right now tell you which times are going to be better to use your and which times are going to be best to use your nested if statement. That really comes down to the individual case and what you're trying to accomplish with the if statement overall. But with that being said, I'm going to assume that you guys are pretty comfortable with everything so far, and so we can move forward to talk about loops. So first of all, what are loops? Because they're actually a little bit different from our if, else if, and else statements. Well, a loop is essentially a way to execute lines of code, or a line of code, multiple times, even though we might only actually write the code once. Okay, so this comes in particularly handy when we're dealing with doing the same repetitive task lots and lots of times, particularly when using stuff like arrays. Loops go really well with arrays because it's a nice easy way to iterate over every element within an array. We'll get to loops and arrays in a little bit. Let's first talk about just a basic while loop, because arrays and for loops go really well together. So a while loop actually starts off looking a lot like an if statement, but instead of only executing the code inside once and exiting, we're going to execute the code over and over again until the test fails. Okay, so let's consider this example. It might be a bit silly, but perhaps we have some kind of an endpoint, we have a starting point, and we're trying to see how far it is to get to that point. Now, the simplest way, obviously, would be to get the end value, get the start value, and just subtract them, and that will give you the number of steps you have to take to get from point A to point B. But let's assume that we wanted to actually print out our progress as we go. And besides, there might be other obstacles in the way, we might have to backtrack or something, so it's not always apparent exactly how many steps we need to take. So what we'll do is start out with an endpoint variable, so let's call this endpoint. This is just going to be equal to 10 or something, okay? We should have a start point here. Let's just set this equal to 3 arbitrarily. And our goal here again is to reach from start point to end point, and again print out our progress as we go. Now honestly, we could change start point in this particular example, but let's assume that start point and end point are fixed and we don't want to change our values. So what we want is something like current position, and we're just going to start by setting this equal to start point. So current position now has the value of start point. So the simplest way to do this would be to add in a while loop. So we'll start by typing while, and then we want to put the condition that we'll test after this. So in this case, we'll keep going until we reach our endpoint. So while current position is less than our endpoint, okay, then we're going to execute some code. In this case, we will simply increase current position by 1. So current position plus equals 1. So note how this looks actually almost exactly like an if statement, but is different in its execution, because we'll basically execute this over and over and over again until this fails. That's different from the if statement, because in the if statement we perform this test, we execute the code, and that's it. We're done. So now what we want to do is actually print out our value of current position as we go. Okay, current position. Okay, actually, no, we don't want that in quotations. Not sure why I was doing that. And I guess we can print our start current position just to, just to solidify the point here. So now if I were to run this, okay, note how I get all these numbers being printed out. I started at 3, I moved to 4, 5, 6, 7, 8, 9, and finally finished up at 10, because that is our end position here. So clearly, these statements have been executed multiple different times, as current position's value is changing every time and is being printed out every time. Specifically, this loop has run 7 times, with the first position being the initial value, so that one doesn't count. So the way this works is we start out with this test, and we say, okay, current position is indeed less than endpoint, because right now it's only at 3. So we'll execute this code, we'll increase it by 1, and we'll print out its value. And that's the first iteration done. Now, because this is a while loop, we need to go back up to the top, and we need to test this again. Okay, current position is now 4. It's still less than endpoint, so we'll execute this code. Now current position is 5, still less than endpoint, then 6, then 7, then 8, then 9. Finally, current position would be 10, because we've increased it by 1. So then when we go to perform this test, we say, okay, current position is 10, endpoint is 10. 10 is obviously not less than 10, so this test fails, and so we can skip over this and exit out of our while loop, and then execute any code down here, which doesn't exist, but if there was code, we'd execute it. So that is the basics of the while loop. Again, very similar to an if statement. It's just you execute it basically over and over again until this test fails. Now that being said, if this test never fails, then you get stuck in an infinite loop, and that's very bad, because obviously that's going to cause your program to crash and to fail. So when designing while loops, you always want to make sure that there is some way to exit out of the loop, and at some point this test will fail. That being said, this test could also fail right off the bat if for whatever reason our start point was at like 11 or 12, then we actually get no loop iterations. So although they might sound scary and complex, loops are actually not so difficult. It's just a way to execute the code over and over again until this test fails, but that's your basic while loop. Now we're going to get into for loops, and like I said, for loops couple really well with arrays, so why don't we use that example. So I'm just going to create a simple number array here, just going to call this num array. Okay, and it's just going to be a list of a bunch of numbers. I'm just going to enter in some random values here. 9, okay, that's good enough. These are just completely arbitrary values. So my goal here is now to go through this array and double each of these and then print out the doubled value. A simple enough task, and we could actually accomplish this without the use of any kind of loop. We could then say something like print num array of 0, for example, times 2. Okay, that's going to print out my first number multiplied by 2, and that's what we want. And I could just do this 5 different times for each of the elements here. But first of all, that's a very impractical way and inefficient way of doing things. And second of all, what if my array was like 100 or 1,000 elements long? Well, then that's 1,000 extra lines of code we have to write, which would take ages to write and is just horribly ugly and inefficient. Luckily for us, we can actually write pretty much this exact line of code, put it in a loop, and let the loop do all the work for us. Now, if we're clever, we can actually do the same thing. We can do this with a while loop. We would just have to create an extra indexing variable, but it's much easier with a for loop. So I'll show you how to do that. We start off with a for, okay? And now we'll follow it with some interesting syntax. So just bear with me here, and I'll explain what's going on once I finish writing this. So for I in, actually let's say this for num in num array, okay? We are simply going to print out, actually I'm just going to take this and just paste it right in here, but I'm going to change num array of 0 to num array of I times 2. Oh, and this should be num. There we go. So now it's complete. Now, this is kind of weird syntax if you're not used to it, so allow me to explain what is going on. So we're basically saying for something in num array, and now this is saying for each of the elements within num array, when it comes to that element, we're going to call it num, okay? So at the beginning, and then we're going to execute this on each of those. So at the beginning, num is going to jump to the first element in this array, okay, because this is a for in loop, and that's how they work. They start at the beginning and finish at the end. So num would take on the value of 13, because this is saying 13 is the first element, okay, and we are at the beginning of the loop and at the array, so num is going to equal 13. And now we're just going to print, oh, and not sure why I went for indexes. This should actually just be num times 2. Apologies on the faulty syntax there, okay? So this is just going to take whatever value num currently holds, times it by 2, and then print it out. Now, once we finish up, we'll get to the second value in num array, which is 53. Again, num will equal 53. We'll print 53 times 2. Then the third value, num is 2, print that times 2, then num is 67, then num is 9, and then after that, we say, okay, num array is finished, there are no more elements in it, so then we're going to exit out of this loop. So this is why it works so well with arrays and lists, is because we can simply say, for each of the elements within this array or list, we're going to call this variable and have it take on the value that we're currently on in the array, and then we're just going to do something with it in the loop. So if I were to execute this, I get these numbers being printed out. I start with 26, then 106, then 4, then 134, then 18. So it is essentially exactly doubled each of these numbers. Now, the great thing about for loops versus something like a while loop is I know exactly how many times it's going to run. Also, I know it's going to start at the beginning of my array, it's going to end at the end of my array, and it's going to visit every single element within my array. Now, that's not the same for while loops. We have to design the code very carefully when doing essentially the same thing in a while loop. And that's because we might not necessarily know where to start in the loop, we might not know where the loop ends, and then again we'd have to create some kind of an indexing variable. This, on the other hand, is kind of doing all of that for us. It's saying, okay, so num is equal to num array of 0, we're going to do that. Then num is equal to num array of 1, then we'll do that, then 2, then 3, then 4, and that's it. I guess there are only 5 elements there. Alright, so those are basics of for loops, just a really handy way to visit each of the elements within an array and then do something based on that. Now, similar to our if statements where we had nested if statements here, we can actually have nested loops. So if I had like an array of arrays and I wanted to iterate through that, I'd probably use a nested loop to do so. But nested loops can get a little complex and can be very slow. So as much as possible, try to avoid doing them. However, in some situations, it is just the only way we can solve a problem. Otherwise, that is your basic loop intro. So as always, do be sure to practice this a lot. I know loops can be I know they can be a weird and difficult concept to understand, especially if you've never seen loops before. So you definitely want to practice a lot with them. But essentially, we use while loops when we don't necessarily know how many times we're going to run. And we use for in loops or for loops when we want to iterate through array elements, or we want to specify a range and know exactly how many times we want to run. So for example, I could do something like range 0 to 4 and just do something like that instead. Okay, but for loops are best used when we know exactly how many times we're going to run. So with the conclusion of for loops comes the conclusion of our control flow section. So we covered just the if, else if, and else statements and then slight variations, and then we covered while loops and finished up with for loops. So be sure to write some practice of your own. Again, Python's really good for just writing quick code and running it and kind of demonstrating how the concepts work. So once you're comfortable using the if, else if, and else statements and then while and for loops, let's move on to the next section, which will be dealing with basic functions. And be sure to try and test stuff like nested for loops and while loops, and then stuff like the nested if statement and then and or operations as well.